All right, today we're going to be talking a little bit more about logarithms. Last week we talked about how to rewrite them as exponents and how to solve them. But now we're going to talk about what do we do if we have logarithms with a product, like a logarithm of two things that are being multiplied together, or things that are being divided, or things that are raised to a power. And we're going to talk about how to expand logarithms and how to condense them. Okay, so the first thing we're going to talk about is expanding. And if you think about expanding, kind of like our belt buckle after Thanksgiving dinner, we have to let it out. It's going to be getting bigger. It's going to be expanding. Okay, so you're going to be going from one little logarithm and expanding it into two or more logarithms. Okay, the first one we have is called the product rule. And the product rule means that if you have a logarithm and you have something that's being multiplied in the solution part, then what you're going to do is you're going to actually expand it by changing this multiplication into addition, because multiplication and addition, those are your inverses. Okay, multiplication and addition are inverses of one another, and that's very important for this next thing. Okay, here's what that's going to look like. Okay, the logarithm of a product is the sum of the logarithms. So in this case right here, we have the logarithm of the product of m times n. Okay, that's being multiplied. If we want to expand that, then we're going to write it as log base b of m, right here, plus log base b of n. We're just expanding it. We're splitting that one logarithm into two logarithms. Now, we did not change the base. The base stayed the same. All we did was we split up this product right here and we put a plus sign in between. Okay? Connection. When we multiply exponents with a common base, then we add the exponents. Kind of like if we had x to the third plus x to the fourth, x to the third times x to the fourth, we would just add those exponents. So that would be x to the seventh. That's the same thing here. We're adding exponents, okay? Don't let that confuse you. Okay, expanding them using the product rule. Okay, so the first one that we have, this example that we have, it says log of 4x. Okay, this is a product right here. This is actually 4 times x. We just didn't have to write the multiplication rule. So if we were going to expand log of 4x, we could rewrite that as just log of 4 plus log of x, where all we're doing is we're just splitting the 4 and the x. Log of 4 plus log of x. Okay, so let's try it down here. For example A, I've got log base 4 of 7 times 9. Okay, we're multiplying right here. So what we're going to do, we're going to write this as two separate logs. So the first part is going to be log base 4 of 7. So I grab the first part. And then I get log base 4 of 9. 7 and 9 have been separated. Notice once again, the bases have not changed. Log 4 over here, still log 4 over here. All I did was split these up and slapped a plus sign in between them. Okay, let's look at B. Now, I have a product, even though there's not a multiplication sign in there like there was in example A, this is still 10 times x. So I can split that up into log base 10 plus log base x. Well, now, once I do that, I actually have something that I could solve right here. Log of 10, if you type that into your calculator, log of 10 is actually equal to 1. So that would actually end up being 1 plus log of x. Now let's talk about why this turned into a 1. Remember we said anytime you have a log and it doesn't have a base, then it's actually a log with a base of 10. So if there were a little 10 down here, we'd be saying log of 10 divided by log of 10. Well, anything on top of itself is going to be equal to 1. Okay, now we've got the quotient rule or the quotient property. Okay, so now we said that the inverse of multiplying is addition. So now we're going to do quotient. We're going to be going from dividing. So the inverse of dividing is subtraction. Now, guys, this is going to be almost the exact same thing as we just did with the product property. But instead of us putting a plus sign over here, we're going to be putting a minus sign. Okay, so here's what it looks like. The logarithm of a quotient, meaning we have division, is the difference of the logarithms. Okay, so now if you think back when we're talking about exponents, when we were dividing with exponents, we subtracted them. Well, this is the same exact thing. When we're dividing with logarithms, we're going to subtract them as well. So let's see what that looks like. All right, so if we have this logarithm and we're doing a quotient, okay, the first thing I've got is the log of x divided by 2. So I have the logarithm of a quotient. So the log of x divided by 2 is equal to the difference of the logarithms. So notice log x gets written first because log x is the first number. Or log x would be what's on top if we wrote it as a fraction that was one over the other. So log x minus log 2. All right, so let's go down to example A and take a look at it. Okay, I know I've got division. I've got this division sign here. So I say, all right, if I'm going to solve this, then I'm going to have to write this as the difference of 2 logs. So the first one I'm going to write is log base 7 of 14, because it's written first, minus log base 7 of x. The 14 came first, x came second. All right, letter B. I've got log, I don't have a base, but remember if there's no base, then it's understood to be a little 10 down there. Log base 10 of 100 divided by x. So that's going to end up being log of 100 minus log of x. Now log of 100, we can simplify that. Log of 100 would simplify down to 2. So 2 minus log of x. Got one more. Okay, we got the power property. Okay, the power rule. All right, if we have a logarithm and it's going to be raised to a power. Okay, so that's like me saying I've got a logarithm of x to the third or 2x squared, something like that. We have an exponent right here in the logarithm. All we do is we grab that power and we swing it to the front of the logarithm. See how this x just got put in the front? So now it's x times log base b of m. Okay, when we use the power rule to pull the exponent to the front, we say that we are expanding the logarithmic expression. Okay, so here's what that looks like. Okay, if we're using the power rule to expand this, all right, in letter A, I've got log base 5 of 7 to the 4th power, I'm sorry. All I do is I grab that 4, I'm going to swing it out here in front of the log, So it's going to end up being 4, because 4 comes to the front, log base 5 of 7. 7 stays put. The only thing that moved was the exponent. Okay, now let's take a look at B. I've got the log of x square rooted. Now, the square root can also be written as x to the 1/2 power. That's just the relationship. So if I was going to write that as x to the 1/2 power, now I grab that power and I'm going to swing it to the front of the log. So it's going to end up being 1/2 log x. Okay, so looking at my properties, this is just kind of a summary. So my product rule, if I had multiplying, it's going to expand to log base b of m plus log base b of n. My product rule, multiplication expands to addition. My quotient rule, division, is going to expand to subtraction. Notice I'm saying they expanded because on the left it was pretty simple, but on the right I got 2 logs and an addition sign in between them. We broke it out. Then the power rule, we just take our exponent and we move it. Okay, now another note, in all cases m has to be greater than 0, meaning m has to be a positive number and n has to be a positive number. We're talking all positives with logarithms, and we'll talk more about why that has to be. Okay, so let's try these. Okay, using our properties, let's expand each expression. All right, in letter A, I've got a few things going on. In letter A, I've got x squared, and I have square root of y. Now, we said one thing about square roots of y. We could rewrite that as y to the what? We could rewrite that as y to the 1/2. Now, if we were going to expand that, this is being multiplied here. So I have log base b of x squared plus log base b of y to the 1/2. But I'm not done because I can't leave these exponents right here. Remember that product property. We've got to grab that 2, swing it on down, 2 log base b of x plus 1/2, swing the 1/2 down, log base b of y. Okay, let's look at example B. All right, example B. First of all, when I look at it, I know I've got division going on. I'm also looking at this cubed root of x. Okay, now let's see. This was the square root, and we wrote that as y to the 1/2. This is the cubed root, so we're going to rewrite this as x to the 1/3. We wrote this as y to the 1/2 because this is a square root. But this is a cubed root, so this is going to be x to the 1/3 when we rewrite that one. So I've got log base 6 of x to the 1/3 minus, because this is a division problem, log base 6 of 36 y to the 4th. Now, I can't leave these exponents in here. We wouldn't be finished. So I got to grab these exponents. I grab that 1/3, swing it down to the front. So it's going to be 1/3 log, oh goodness, I'm sorry. I didn't even notice that we had to expand this over here. Over here, I've got 36y to the 4th. This is multiplying, right? 36y to the 4th. So we can expand that a little bit more. Now I got log base 6 of 36 plus log base 6 of y to the 4th. That y is supposed to be up. Now look at this one. Log base 6 of 36. We can even simplify that even further. And then we've got our 1/3, our exponents were brought down. So I got 1/3 log base 6 of x minus log base 6 of 36 minus, look, my 4 came down, log base 6 of y. Log base 6 of 36 is actually equal to 2 because 6 squared is 36. And remember, you could type this in your calculator, log of 36 over log of 6, and you'd still get 2. Okay, so let's expand these. All right, now, when I'm looking at this, let's think about how many parts we're going to have to begin with. First thing I've got, I have a 3, so that's going to be 1 part. I have an x, that's going to be 2 parts. And I got a y squared, that's going to be my 3rd part. So whenever I expand this log, I'm going to have 3 parts when I expand it. Now another thing, this y squared, the squared only goes to the y. This 2 only belongs to the y. It doesn't go to the x, it doesn't go to the 3. So the only one of these parts that's going to get this exponent is going to be the y. So if I start writing this as I expand it, I'm going to have log base 2 of 3. Okay, we got multiplying here, so I'll write a plus sign. Log base 2 of x plus log base 2 of y squared, but I can't leave y squared. So I have to take that squared, bring it down in front of the log, so then it's going to be 2 log base 2 of y. But now look, that 2 only went to the y. So that's why the y is the only one that's got the 2 in the front. Okay, let's look at our second one. I've got log base 8 of 2 to the 6. Okay, so that's going to be 1 part. And the 2 has an exponent. Then I've got x times y squared. Now here's the difference. This one, the one we just did, it didn't have parentheses. This one does. So since it's got parentheses right here, what that's really saying is x gets the squared and y gets the squared. So they're both going to get that too. So if we're going to rewrite that one, okay, the first thing I'm going to have is log base 8 of 2 to the 6. That was my first piece. Plus log base 8 of x squared plus log base 8 of y squared, because the squared goes to both of these. Now every one of these has an exponent, so I'm going to have to bring that exponent down on every single one of them. So I've got 6 times log base 8 of 2 plus 2 times log base 8 of x plus 2 times log base 8 of y. Got to bring down all of those exponents. Okay. And then a final note, it says you are expanding, not condensing these logs. So you're supposed to be making it look more complicated. Now, sometimes they're going to ask us to condense it. Condense means to make it smaller. Kind of like after Black Friday, I need to condense my closet because I am running out of clothes hangers. Got to make it smaller. Okay, so it says to condense a logarithm, we write the sum or difference of 2 as a single expression. So what you're really doing, you're going to be squishing them back together. You're doing the opposite of what we just did. Now we're going to be going from a big logarithm expression and squishing it down to where we only have 1. okay? You'll be using properties of logarithms to do so, the same properties that we just talked about. Okay, so here's all of our rules. All they are is flip-flopped. If we have two logs that are being added together, we're going to rewrite them as multiplication. We're just going back the other way. If we've got a quotient rule, if we've got subtraction and we want to condense it, we're going to rewrite subtraction as a division. And then the power rule, if we have a number being multiplied in the front, when we rewrite it, we're going to rewrite it as an exponent. The same rules, we're just going in the different direction. Okay, so condensing these logs and writing them as a single logarithm. Okay, let's go backwards. Remember, we said that addition and multiplication are inverses of each other. Okay, so if I were going to squish log base 4 of 2 and log base 4 of 32 together, it is addition now, but when we squish it together, I'm going to multiply them. So 2 times 32 is 64. Now I can actually simplify that. Log of 64 over log of 4. And I get 3. So I'm condensing it. I'm making it smaller. I'm making it simpler. Okay. Now let's look at the next one. That's supposed to be example B. I'm sorry. It says log of 4x minus 3 minus log of x. Okay, I have subtraction. Subtraction and division are inverses. So I'm going to rewrite this as a log with a division in it. So it's going to be log of 4x minus 3 over x. Now I wrote the 4x minus 3 on top because 4x minus 3 is listed first. Okay, now it says coefficients of logarithms must be 1 before you condense them using the product rules. Okay, so that means we've got to rewrite these coefficients. You know, this is just like in those other problems, we brought them down as powers. We got to put them back up as powers before we can condense these logs. So in A, I'm going to have to put that 1/2 back with the x. Now, ooh, we knew something special about x to the 1/2. X to the 1/2 could be rewritten as the square root of x, right? Okay, so if we move that up, log of x to the 1/2 plus, let's put that 4 back up there, log of x minus 1 to the 4. Okay, now we want to condense it down a little bit more. I've got the log of the square root of x times, because remember we're condensing it, times x minus 1 to the 4th. Once we have plain old log here and plain old log here, then we can go ahead and condense it. So now in letter B, before we can condense these, before we can write this as division, I got to get rid of this 3. So I got to take this 3 and I'm going to rewrite the 3 as a power. Now I can write it as division. So I'm going to write it as a single log with x plus 7 to the 3rd on top and x on the bottom, condensed. All right, letter C. I got to move the 2 first before I can do anything. So I've got log of x squared plus log of x plus 1. Now I have addition, so when I squish it together, it's going to be multiplication. So it's going to end up being log of x squared times x plus 1. All right, let's see if we got it. Let's rewrite it as condensed log, okay? Letter A, we don't need to move anything. Letter A, we're doing good, don't have to move anything. So it's subtraction, so I'm going to rewrite this as a division problem. So it's going to end up being log base 3 of 20 over 4. Now, is 20 over 4 simplified? No. 20 divided by 4 is equal to 5. Log base 3 of 5 would be our final answer. All right, letter B. I've got to take this 3, make it an exponent again. So it's going to be log base 2 of x to the third. I have a plus sign, so this is a multiplication. So I've got x to the third times y. Remember, the inverse of adding would be multiplication. Inverse of subtracting is division. All right, letter C. Letter C, I'm going to have to do a few things. First, I got to get rid of this 3. So I'm going to take this 3 and I'm going to make it an exponent. So now that's going to be log of 2 to the third plus log of 4 minus log of 16. Log of 2 to the third plus log of 4 minus log of 16. Now, this is kind of like order of operations. 2 to the third, 2 times 2 times 2, that's 8. Okay, these two are being added, so I'm actually going to be multiplying whenever I condense it. So 2 to the third, we said that was 8. So 8 times 4 is 32. So this would condense into log of 32. But now I got this minus 16. So I'm going to have log of 32 over 16. And 32 over 16 reduces down to log of 2. Okay, now identifying the properties of logarithms. State the property or properties used to rewrite each expression. Okay, the first one, I'm going from log base 2 of 8 minus log base 2 of 4 into a division. So what's another word for division? What do we get when we divide? We get the quotient. Now this one, we might have two things going on. I got me a power and I got me some multiplication going on. So I'm going to have two different properties on this one. I got to deal with that power and I got to deal with that multiplication. So I'm going to have the product rule and the power rule in that one. And then this last one, I've got log base 5 of 2, log base 5 of 6, and looks like all I did was condense it. That's going to be the product rule. Okay, demonstrating properties of logs. Okay, we know a couple of these approximations. Okay, I know log base 10 of 2 is about 0.031. And log base 10 of 3 is about 0.477. Okay, so in A, if I rewrite this as log base 10 of 2 minus log base 10 of 3, well, log base 10 of 2 we know is 0.031. And we know log base 10 of 3 is 0.477. So we can subtract these two numbers. So whenever I subtract those, I end up getting negative 0.466.